Reminder of what we've done before. Really, this is what we're going to be using. Can't write in white. This is what we're going to be using mostly with the application word problems. You can use the secant, cosecant, and cotangent, but there's no need to do that. It just makes it more difficult. Then you have to remember how to put it in the calculator, and maybe you do it wrong. So sine, cosine, and tangent, your SOHCAHTOA. And you can't say, well, I'm going to always use sine because that's my favorite, I like it. It all depends on the sides and the angles that you're given, which of those three trig functions you can use. Sometimes you can pick one. Sometimes only one works, depending on what is given in the problem. This first problem, it gives you some information. It tells you you have triangle ABC, and it tells you which angle is the right angle. So I would suggest drawing a right triangle. However you draw that, doesn't matter. What does matter is that your angle A is 90 degrees. So wherever your 90-degree angle is, has to be angle A, because the problem states that. You can't change what that is. If that is angle A, and the angles are always represented with capital letters, the sides are represented with lowercase letters. If this is angle A, side A has to be across from it. You can't just pick where you want side A to be. Side A has to be right here. So the hypotenuse in this problem has to be 29. Yes?
So the 90 degrees won't always be like with the A?
Could be R, L, Q, S. 26 different letters it could be. Then B and C. So we have two more angles left, B and C. This does not matter which one, where you put B and where you put C. Okay, so I'm going to put B up here and C down here. Again, it doesn't matter. C could be up here and B down here. Now, once you decide, you can pick your sides or your angles first. It doesn't matter. But if I choose to put B up here, then I have to put little b over here, which is 21. 21 has to be across from its angle. Little b has to be across from big B. Little c has to be across from big C. Now, c's kind of are the same. Little c and a big C, capital and lowercase are the same. Be sure you don't just always use lowercase, always use uppercase. Angles are uppercase, sides are lowercase. The only time where it wouldn't necessarily matter is if you're doing some kind of more like word problem and you labeled it something. As long as you don't label two sides and angles or side and angle the same letter, both capital or both lowercase, then you'll be okay. But if it's just a regular general triangle, you have to follow what it says. All right, so the other thing, it could just say solve the triangle. If it says solve the triangle, you find everything that's missing. Every triangle has 3 sides and 3 angles. All the angles add up to be 180. If you don't remember that, you need to know that. So if we had 2 angles, all we would have to do is use add and subtract. But we don't have 2 angles, so we're going to have to use some trig to find one of the angles. Before we do that, we could find side C, right? C squared, not equals, C squared plus 21 squared equals 29 squared. That's easy. We don't even need precal to do that. So you do that in your calculator. C squared equals 29 squared minus 21 squared. And you should get C equals 20. Now, someone earlier said, well, why is C not the hypotenuse? I thought it was A squared plus B squared equals C squared. Okay? It can use whatever letters. It could be x squared plus y squared equals z squared. R squared plus a squared equals t squared. Like, the letters can be whatever. C is not always the hypotenuse for the rest of your life. It's whatever is in the problem. All right? In this case, C is a side. It's not the hypotenuse. All right, now for one of the angles. Doesn't matter. Now, because we know side C, it doesn't matter which one we find. But I will suggest always using the information that is given to find your answers. Because if we messed up on this, and then we use that to find an angle, there's no way that angle is going to be right. And then it's going to mess everything up. So I know 21 and 29 were given. I know those are right because it came out of the problem. So I'm going to use those to find either angle B, not C because I don't have enough information, so angle B. So across from B is opposite 21, and the hypotenuse is 29. So opposite hypotenuse is sine. So sine of angle B equals opposite over hypotenuse. Because we know little c, we could use whatever we want. We could say the cosine of B equals 20 over 29. We could say the tangent of B equals 21 over 20. There's all kinds of possibilities at this point. You just got to pick one. So this right here, this would be some work I would expect to see. If you need to do one more step, because B is missing, right? That's the angle that's missing. That's what we did yesterday. If we have the side and the angle's missing, we take the inverse. The inverse of the side equals the angle. So that right there, one or both of those steps would be fine for work. You don't have to show them both, but at least one of those steps would be the work we would expect to see. If you don't have that work anywhere, you're not going to get any credit for the answer. You have to show one of those two setups right there. The Pythagorean theorem, don't really have to see. That's something you learned a long time ago. We've just learned this, so we want to see, did you know how to put that in the calculator? And if you did it wrong, you'd get some points for this setup. You just didn't know what to do in your calculator. Maybe you were in the wrong mode. We're dealing with triangles, so we have to be in degree mode. Anytime we're dealing with these triangles, degree mode unless otherwise noted in the problem. So we should have got angle B to be 46.397 degrees. So there's another angle. The only other thing we need is angle C. All we have to do is add and subtract for that. Angle C is going to be 180 minus 90 plus B. We just found B. So angle C is 43.603 degrees. So there's your 3 parts. You were given 3, you had to find 3. 6 parts of a triangle, 3 angles, 3 sides, always. It could just say solve the triangle. If it says solve the triangle, that means we're looking for everything. If it gives you a picture and says solve for the variable, wherever the variable is, solve for that. But solve the triangle means to find all of the missing parts. And there are always 3 sides and 3 angles. All right, so these directions that were at the top of your page right there tell you to round to the thousandths when necessary. If you're given an angle that you're supposed to know on the unit circle, then do not use a calculator. On your homework, you don't have to worry about that. It tells you when to use one, when not to use one. On your quiz Monday, you will have the calculator or you won't. You won't have to choose when to use it and when not to use it. If you have it, you can use it. If not, then we know our answers are going to be exact. So this one is a non-calculator problem because of that 30-degree angle. We change that to 20. Now it becomes a calculator problem. All right, so a lighthouse keeper. So lighthouse up here. A keeper, person, standing up at the top of the lighthouse. He's looking around. Okay, an angle of depression between the horizontal and the line of sight to a ship. Okay, so the ship is out here in the water. You don't have to draw a picture. I'm just drawing a picture so you can see what I'm talking about. There's a ship. Okay? So the lighthouse keeper says there's a 30-degree angle of depression between the horizontal and line of sight. That's not even math. Okay? Between. So the horizontal, I look out straight horizontally. Then I look down to the ship. Between the horizontal and the line of sight to the ship. Between. That's not down here. This is not between. My arm goes straight out. I look down to the ship. Here is the horizontal. Here is where he's looking down at the ship, is 30 degrees. That is not here. He's not looking down at the bottom of the lighthouse. He's looking towards the ship. So between the horizontal line, he looks straight out. Then he looks down. That's the depression. Well, transversal, parallel lines, all of that stuff from geometry. We know this is 30. Right angle stuff, we know this is 60. You can find one or both of those. It doesn't matter. And this is a right angle right there. The keeper is 19, so we know this is 19 meters. How far is the ship from the shore? So ship to the shore, make that some letter, whatever letter you want. There's only one letter in this problem, so it doesn't matter what you make it. So we look at what we have. We have 60 and we have 30. We can use either one. We don't use 90. Okay, we can use either of the other angles because 90 has to do across from the hypotenuse. There's no adjacent. If we use 90, how do we pick which one's adjacent? Opposite's hypotenuse. So we can't ever use the right angle when we're doing our SOHCAHTOA. If you like 60 better, use 60. If you like 30 better, use 30. I'm going to use 60. So I'm going to say I don't know the opposite, but I do know the adjacent. So in this problem, it doesn't even matter what the hypotenuse is. We don't even care about that. So I'm going to say the tangent of 60 degrees equals opposite over adjacent. If you like the 30-degree angle better, the tangent of 30 degrees equals 19 over x. You're going to get the same answer, you just have a different setup. So this right here would be the work I would expect to see. That's what I would expect to see. Now, it's a non-calculator problem, so we've got to use our unit circle to figure out what the tangent of 60 degrees is. So unit circle, here's 60 degrees. That's 1/2 root 3 over 2. Tangent is y over x. Can't divide fractions. I multiply by the reciprocal. So the tangent of 60 is equal to root 3. Solve for x by multiplying by 19 on each side. And there's your answer. 19 root 3. And we are in meters. We change that 30-degree angle to 35 or 20 or 25, 31. We do that same exact stuff. It's just with a calculator. Let's say we change that to a 20-degree angle of depression. That changes that 60 to 65. Then we just do tangent of 65 times 19. Press enter, and you have your answer. That would be the difference between a calculator versus a non-calculator problem on this.
So you know it's not calculated because it's an angle. An angle's given.
That's on the unit circle. So right here, if you were given an angle, you were supposed to know that is on the unit circle, then do not use a calculator. Okay. You don't have to decide on your homework. It tells you exactly which ones. Page 227, number 7, no calc. 35C, no calc. No calc. 15C, it tells you exactly what to do. You don't even have to remember 30, 45, or 60. Hopefully you can, but you don't have to. All right, next one, a 20-foot ladder is leaning against the building. The base is 6 feet from the building. So we have 2 questions on this one. All right, so here we have the ground. Here's a building. A ladder is leaning against that building. It is 20 feet. The ladder from the base of the building is 6 feet. We want to know how high does the ladder reach on the building. I'm going to call that x. So we have 2 questions, the angle of elevation and how high is the ladder reach on the building. Since we know 2 of our sides, we could go ahead and say 20 squared equals 6 squared plus x squared. And then when we solve for that, we get 19.079 feet. So there's one question. Now, since one is what is the angle of elevation and one is how high, one of them is going to be feet and one of them is going to be in degrees, so it is very obvious which one is which. Just do not label them with the same letter. Now, if you use big X and little x, that's fine. Okay, but make sure your x's are different sizes. So I'm going to call this angle A, just to not get confused. Whatever you want it to be. Just not the same. Can't be exactly the same. It can be capital and lowercase, but it can't be exactly the same. All right, so here, angle A. I'm not going to use that 19. I'm going to use 6 and 20. All right, so If this is A, 6 is adjacent, and 20 is hypotenuse. So that is cosine. Cosine of angle A is equal to adjacent over hypotenuse. If I'm looking for the angle, I have to take the inverse. So the inverse of 6 divided by 20 equals A. And when we're dealing with triangles, we're always in degrees unless it tells you otherwise. So these word problems are going to be in degrees unless it tells you otherwise. So, yes? It just depends where you're looking. Like the other one was a lighthouse. We were up and we had to look down. Like, so if I look out, so that could have changed. Maybe the lighthouse keeper looked up at the sun. So elevation, if I look up at the sun, that's an angle of elevation, horizontal up to here. But if I look down, then it's depression. And sometimes they end up being the same, like because of transversal and parallel lines. It's just label them correctly so that you don't put them in the wrong place. So this one, we want to know the angle of elevation of the ladder. So if the ladder's on the ground and you pick up the ladder, so here's the ladder on the ground, you pick it up and put it there, this right here, that's what would create our angle of elevation. If someone was, let's say, standing at the top of that building and looked down at a car, it'd be the angle of depression, but then because of parallel lines and transversal, it would end up being that same angle right there. You just have to read the problem and see where you're standing or wherever the thing is you're looking from or to or at is going to be. So when you solve this, you should get 72.542 degrees. Again, these word problems are always going to be in degrees unless it states otherwise. All right, measure of each angle of an isosceles triangle. Isosceles means two sides are the same. Maybe we forget that. Doesn't matter if we know that or not in this problem because it tells you 6, 12, and 12. That tells us it's the same. So if one side of a triangle is 12, no matter where that side is, that side doesn't change. If it gets bigger, the angle gets bigger, the side gets bigger, vice versa. If the angle or the side gets smaller, the other one gets smaller. So it just means these are the same. So these would be 12, 12, and this down here would be 6. Now, isosceles triangle doesn't help us with right. All we know is how to solve a right triangle, SOHCAHTOA. We don't know how to solve a non-right triangle yet. We'll get there, but we don't know that yet. Say that. Split it in half. Back to geometry, angle bisector, segment bisector, all that stuff. So we split it in half. So now we do have a right triangle. So this would be now 3 and 12. Now remember, this angle and this angle are the same. So once we find one of them, we know them both. You can name it whatever you need to name it something, so it's in the problem. I'm just going to name it A. If you want to find that hypotenuse, you can, or this side you can, but there's no need for that. We don't have to know what it is, so we could just say cosine of A equals adjacent over hypotenuse. So the inverse cosine of 3 over 12 equals A. One of these two steps, doesn't matter if you show one or both, one of those steps would be the work to show for this problem. At minimum. You can show more, but at minimum, one of those two steps for your work. Could you simplify that to be 1/4? Yes. Do you need to? No, because calculator will not do, it'll do everything for you. There's no need to simplify it and accidentally make a mistake on your simplifying. You can just type it in just like that, and you get 75.522 degrees. That means another one is 75.522 degrees. It says find the measure of each angle. So that means we're just going to have 3 angles. You don't have to name them or label them. Just find all 3 of them. And then for the other angle, all of them add up to be 180. So 2 times your 75, or 75 plus 75, those angles, don't type in rounded answers. scroll up and grab it, or use whatever method, store it as a letter, but never ever type in rounded answers. And then for your other one, you get 28.956 and degrees. So this is different from that first one in that specific angles didn't equal something. It just said find them. So you don't have to tell me. If you labeled them and told me A, B, and C equals, that'd be fine, or RQL, whatever letters you like. But you don't have to on this problem like you did the first one we did. All right. All right, so I drew a little picture on this one for you so that you can kind of see what is happening. You do not have to draw pictures, but I can tell you that pictures, and they don't have to be elaborate. Hey, just draw some triangles on there and label and list things that are happening. So, two motorcyclists spot a helicopter flying at 2,300 feet. One of them, when they look up, is 32 degrees. One of them is 50. So if I look up, let's say, the corner of that wall, and that's 32 degrees, think about when I would be closer or further away, because then your answers are going to make sense. So this is my angle of elevation at the corner of the wall right there, but as I walk closer, notice my angle is getting bigger. So the closer I am, the bigger the angle is. The further I am away, the smaller the angle is. Therefore, your line of sight or your distance from the helicopter is going to be smaller at 50 and bigger at 32. All right, so tells us the two lines of sight. How far apart are they if they're on opposite sides of the helicopter? All right, so let's just say this one's 32 and this one's 50. And this is 2,300. Okay, it doesn't matter which one you label which. Either one is fine. We want to know how far apart are the two bikes. So basically we have two triangles here. We have a 50, a 2,300, and I'm going to call that X. And then over here, this is still 2,300. This is 32, and I'm going to call that Y. Just do not call them the same. X1 and X2, A1, A2, X and Y, A and B, R and L, whatever you want to use. So this next part are the setups that I would expect to see. So we want to know X and Y right here. So looking this angle, this is opposite, this is adjacent. So your setup that I would expect to see is tangent of 50 degrees equals 2,300 over X. And then over here, tangent of 32 degrees equals opposite over adjacent. You want to use cotangent? Just be flip-flopped. Fine, I wouldn't, because it's harder to put cotangent in. I mean, it's not impossible to put cotangent, but it makes more sense to use sine, cosine, or tangent on these. Now, if you don't know what to type in at this point, hey, that's the work I would expect to see. That right there, I would expect to see those setups for you to get credit for your answer. If you can't figure out what to do, make it a proportion. X times the tangent of 50 degrees equals 2,300. Then solve for X by dividing by the tangent of 50. Those cancel. Again, this one, of the two answers, this one's going to be the smaller number. So you should have gotten 1,929.929, and then whatever happens there. Over here, Y equals 2,300 over the tangent of 32 degrees. And that one you should have gotten 3,680.769. Repeating. Now, on these, because we're adding integer, well, not really integers, well, we're adding numbers right here. Whether we rounded those or not, it doesn't always matter. But here, like if that third number didn't rounded and when we didn't add them together and then changed when we added them together, it would make a difference. Okay, so always, always wait to round until the very end of your answer. Don't ever type in rounded answers into your calculator. Always scroll up and grab or store. So 5,610.699 feet. Because if you are ever more than 1/1000th off, that answer is wrong, because that means you typed in rounded answers into your calculator. 1/1000th means a rounding error. More than that means you typed rounded answers into your calculator. Never ever type in rounded answers. Also, don't use that feature on your calculator that cuts them off at 3, because that will mess up every single one of your answers in the next couple units. If you don't know what I'm talking about, terrific. Don't ever use that, because it will mess up everything. Sometimes it'll work, like right now it's fine, but from this point moving forward, it will not work for anything, because it ignores all those other things, and when we start squaring and multiplying and dividing, your answers will be way far off and everything will be wrong. So do not use the feature on your calculator that just shows you 3 digits. And this last one is just a reminder of your SOHCAHTOA. Depending on what angle you're looking at, changes the opposite and the adjacent. The hypotenuse, this is always the hypotenuse, always. We would never ask for the sine, cosine, or tangent of the right angle. It's only the other angles. So sine of A, 24/25. Cosine of B, notice that's still 24/25. So that's possible because we're looking at a different angle. Tangent of A, opposite over adjacent. Well, we don't have an adjacent right here. If we know that's a triple, we can just put a 7. If we don't know that's a triple, 25 squared minus 24 squared, take the square root, and you get 7. So tangent of A, 24/7. Cotangent of B is the reciprocal of tangent, so 24/7. Adjacent over opposite. Hypotenuse over adjacent. Oh, where am I? Which one? D of B. 24/7? Did I not write that? What did I write? Is that not right? Cotangent of B is adjacent over opposite. Adjacent over opposite.
Wait, so what's tan?
TOA. Opposite over adjacent.
And then cotangent is adjacent.
The reciprocal.
They're the same.
This is tangent of A
Oh.
and B. So that's why we're doing this. So we see that they could be the same, but depending on what angle we're looking at. Secant of A, hypotenuse over adjacent. Cosecant of B, hypotenuse over opposite. So you can't just say they'll never be equal, they'll never be the same, because they could be the same. It all depends on what angle you're looking at and what you're going to use. But for these word problems, use sine, cosine, and tangent. No need to ever use secant, cosecant, or cotangent.
So those would still do like cotangent, the little negative one, the little inverse thing, and then in parentheses 24/7 equals D.
Oh, if we were finding the angle?
Yeah.
Yes, if it asks for the angle. Yep. Couple things. Remember, I said this a while ago, but your Quiz Monday covers today's unit, so the homework key will be on Moodle this afternoon. Also, we will give you a blank unit circle on Monday, so you can fill it out as much or as little as you need. We won't grade it, but it'll be there for you to have.